Let's revisit the parameter exploration scenario, but now in the context of multi-node jobs, so basically MPI, or multi-core jobs, OpenMP. So again, we have a certain application, the weather application, but actually now it is an MPI application, so it can run distributedly on multiple nodes. And for instance, we might want to run it with 72 processes, 2 nodes, 36 cores each. And of course, we'd have to use MPI run in order to launch our MPI application on multiple nodes. Apart from that, the example is similar to the one which we discussed previously when we were talking about parameter exploration. And of course, you could just launch any number of such jobs, and basically that would work. But again, just like before, the burden of administration, the burden of bookkeeping would be on you. So in this case, we have many multi-node computations. The solution, in order to get this done more efficiently from your point of view with respect to bookkeeping, is to use aenv. aenv is part of atools. atools is a suite of commands which is useful in order to deal with this kind of jobs. So again, we start from our data CSV file, and in this case, we modify our job script slightly differently. So we start by loading the atools module, and then we source a file handle that's created by aenv, and that is file handle is created based on the data.csv file. So what it essentially will do is ensure that the environment variables pressure, temperature and humidity are initialized correctly for this particular job. So basically, aenv will take a row out of that CSV file and will initialize the environment variables appropriately. Okay, then we can compute the array IDs using arange, and again we do that based on the data.csv files. And we assign that to the environment variable arrays_id. And then we just use qsub with the -t command line option and the array IDs we computed in order to set the range of PBS array ID values. So the steps: typically just write a PBS script with parameters, so in this case again pressure, humidity and temperature, and then you add a line to initialize those parameters using aenv, and of course you have to load the module. You create an Excel sheet with the data, convert it to CSV as usual, and you submit with qsub -t and the range of values which you compute with arange. Okay, so basically what we're using is talk job arrays, and essentially you already know this, I've shown you before. Basically qsub -t with 1 to n 200 will initialize PBS array ID in each of those individual array jobs. Can you support MapReduce? Yes, indeed, but support is basically through the scheduler itself, based on job dependencies. So essentially the prolog has its own job, and you submit that first, and you assign the job ID to the environment variable prolog ID. Then you submit the batch job, the map part if you want, and this is done using qsub again, but with dependencies. And so basically the dependency is an after OK. So if the prolog job starts and completes successfully, then the batch job can actually start. And you again record the batch job ID into the batch ID environment variable, and you use that to do a queue sub for the epilogue, which again has a dependency, in this case on the batch job, and again it's after OK. So essentially you just submit these 3 jobs one after the other, and due to the dependencies, the prologue job will be executed first. When that has completed successfully, the batch job will be executed, and then finally, when the batch job has been executed, the epilogue job can start, and when that's executed, all your work is done. So that's using basically PBS talk dependencies, which you can use in other contexts as well. So essentially, the job dependencies, the prologue would again split the original data file, and basically that's prologue PBS in this case. Then you have a number of job arrays. Well, you have a job array with a number of jobs, and those will not start before prologue PBS has completed successfully. And finally, epilogue.pbs will not start until all the array jobs will have completed successfully. So that's basically how that works.